So in this video, we are going to focus on the trigonometric equations that also require you to think about quadratic equations. This one is not just a quadratic equation because it also has a fraction with a denominator. So you just need to do that extra step first where you think about the domain restrictions that division imposes on your function, because you can't divide by 0, so the denominator can't be equal to 0. So the sine of x can't be 1, and we are going to look at the unit circle to see what value is that. Well, the sine is the vertical axis in the trigonometric circle. So the circle has radius 1, so sine equals to 1 is just the very top of the circle right here. That value is pi over 2, right, at the very top of the unit circle. But that's just not a number that's going to come up as a solution to my equation anyway, because in the next step, I'm going to ask for the numerator to be equal to 0. And if sine was equal to 1, then that's not 0, right? That's just going to be 2 minus 5 minus 3. So that pi over 2 is not actually going to come up as a possible solution to my question. That's not going to matter. It would matter if the problem was slightly different. The only thing that I changed here was this plus. Because now, if you happen to forget to do the domain thing over there, and you just multiply both sides by the denominator, getting to the quadratic equation, then you solve the quadratic equation, you will find two answers, which are 1 and 3/2, but one of them is actually forbidden because of the domain. Okay, so this is why you actually have to do this initial step, even though a lot of times it doesn't matter. It's still safer to show that you know what you're supposed to do. Okay, now for the next step, I've already multiplied both sides of the equation by sine minus 1, so now I only have the numerator. And I've also done another thing here that in terms of notation, I like to do this a lot, which is to shorten my notation. Instead of writing sine of x over and over again on each and every line, which is the correct way to do things, but it can get boring. So sometimes people skip over some of that and just write in a sloppy notation just to make it shorthand and go faster, and also to make it more readable, okay, because the shorter lines are easier to read, so you have fewer opportunities to make mistakes because you don't even understand what you wrote yourself. So it's okay to do that, to shorten the notation. I'm just saying, don't do that in a sloppy way. So far, the problem didn't give you any variable called s or y or z or whatever you're planning to use as a variable. So if you're going to use it, write it down. Just, that's it. You are allowed to change your notation. You just have to write it out explicitly so that it's rigorous. It's not sloppy. So here's my quadratic equation in the variable s. I'm not really going to try to factor this one. I'm just going to use the quadratic formula. A little bit more of calculation, and the final answers that I got for this quadratic were s equals 3 and s equals -1/2. At this point, it's very important for you to remember that the variable s is actually the sign of something. So there are restrictions of the values that it can have. Go back to the unit circle. It can only go from -1 to 1. Those are the possible values of sine. So right here, sine of x equals 3. That is an impossible solution. We don't want this one over here. It's still one of the solutions to the quadratic, so it needs to be showing on your page that you went through it, that you considered it, but then decided against it because it can't be a possible value of sine. So if you want to actually write that out explicitly, you have time to be writing these little notes in your exam, this actually looks pretty good. So s equals -1/2, the other solution here, is the one that we're actually going to be working with in our unit circle. Anytime that you draw a unit circle in one of these questions, it is just a diagram. It doesn't have to be perfect, but make the circle like good enough that the proportions are still kind of right, okay? Because -1/2 is a number that is going to appear very often, and a half is not that difficult to mark kind of precisely on a segment. It's in the middle of the segment, right? So if you do that precisely enough, and then you ask yourself, what are the points on the circle whose sine is that point that you just marked, then the picture itself is already going to show you which one of our favorite angles you should choose, right? Remember, we only really know 30 degrees, 45 degrees, and 60 degrees. So come on, which one is that one out of those three options? It's 30 degrees, right? Just visually, because it's not 45 since it's not in the precise middle, and the other one is bigger. So if this is going to be 30, that one's going to be 60. That looks good enough. But 30 degrees is not the answer to the question, okay? Because this is not in the first quadrant. This is just to know which kind of angles we're dealing with. And 30 degrees is pi over 6. I've just gone ahead and sliced the whole circle like a pizza in slices of pi over 6. And now I'm just going to count how many slices to get here and here. 1, 2, 3, 4, 5, 6, 7. So this one is 7 pi over 6, 8, 9, 10, 11, 11 pi over 6. So guys, I know there's probably way smarter ways to come to that conclusion than just counting up slices of pizza. I'm not looking for smart. I'm just looking for the right answer quickly, and that is the way that I do it. So those are the two answers to our equation, 7 pi over 6 or 11 pi over 6. Here's another one. This one doesn't have that whole denominator domain stuff, so I'm just going to start by solving the quadratic equation. So here are the calculations, and the two solutions for S are 2 and a half. Now 2 is an impossible solution because the sine of x can't be 2, and the other one, S equals a half, is what I'm going to put in the unit circle. Those are the two angles that have that sign, and once again, visually, having to choose between the three angles that it can possibly be, 30, 45, and 60, this one is 30 degrees. All right, so these two questions were very, very similar. Starting from the fact that even the numbers were similar in the beginning, we had a 2 and a 5 for both equations. Then we solved the quadratic equation, and in both cases we found one impossible solution and the other solution was a half. Well, in the first one it was negative a half, but that's basically the same thing. And then that turned into two values of x. Well, that part is inevitable, right? Because for every value of sine, you're always going to have two possible angles, one on the right and one on the left, that have that sign. But I'm wondering how much of this similarity was coincidence, how much of it was lack of creativity on the part of the people who are posing these questions, and how much of it is simply because there aren't that many options. Whenever you're dealing with trigonometric equations on questions that don't allow calculators, there aren't a lot of angles whose sines and cosines you know or recognize. So I would like to propose an exercise for you. Try to come up with as many different quadratic equations as you can. Of course, quadratic equations with a trigonometric there, such that there are interesting answers. Because if you throw random numbers for the coefficients of a quadratic equation, first of all, sometimes there's not even going to be solutions, right? If the discriminant is less than 0, then you don't get any solutions. So that's one thing that you can start with. So the second thing is that in order for it to be interesting as a trigonometric problem, at least one of the solutions to the quadratic needs to be between -1 and 1. Otherwise, there won't be any solutions to the trigonometric equation. And I guess that saying, well, this equation doesn't have any solutions, is a valid answer to a problem if that's the case. But that's not the kind of interesting problem that we're trying to come up with, okay? I really want you to make this effort to sit down by yourself and try to come up with different questions that could be asked, especially if you tend to get the feeling that you're always being surprised by the questions, that you study a lot and you do your homework and you do your worksheets, and then you get to the test and you are surprised because the questions are different. Well, why are you being surprised? Why are they different? Have you stopped to think about how different the questions could be? So give it a try and let me know in the comments some of the equations that you come up with. Let's see if they're interesting. Remember that a half and negative a half that we found here are not the only possible numbers that could be interesting. There's not that many of them, but it's not just half and negative half. If you want to take this challenge up to the next level, here are the compound angle formulas. So maybe you can try for this challenge to increase the number of available angles that could potentially be the answer, right? You're still going to be trying to find a quadratic equation that has interesting solutions, but maybe you don't want to just use 30, 45, and 60. Maybe you can combine some of those using the compound angle formulas to put more numbers on that list, a couple more numbers on the list. I don't know. I would also be very interested to see if anybody comes up with an interesting, different, and creative problem. And this might require your question to have like part A, part B, because there's only so much that you can expect the people solving your problem to know by heart. Now, in the previous video, we solved this equation and I mentioned the possibility of doing it this way. Our original equation here was not a quadratic, but that also happens a lot in problems, that the quadratic only shows up after you've manipulated your equation a little bit, and the Pythagorean identity is a very common tool that we use. So let's try to follow this path now. I mentioned that the next step would be to raise both sides of this equation to the power of 2 now, so let's do that. Notice that the plus or minus here has disappeared because either way, when you square it, it's going to be positive. So now I have two possible values of sine. Let's put it in the unit circle to find the values of x. So as usual, for each value of sine, I'm getting two angles. In this case, I had two values of sine, so I get four angles. It looks like my equation should have four answers, right? But if you've already watched the other solution in the other video, you know that there's actually only two solutions. So two of these are wrong. And I wanted to mention this because it's a situation that is very common to happen. So why is this happening? Where did the two extra wrong solutions come from? What can I do about it? Because I don't want to give wrong answers. And how can I know whether or not this is going to happen when I'm solving the next problem? And the problem was here on this step. One of the steps that we made in solving our equation was raising both sides of the equation to the power of 2. And that is something that we can do. It's doing the same operation on both sides, but it's one of those that we have to be careful when we do. Just like taking the square root, you have to be careful by putting the plus or minus. It turns out that squaring both sides is also something that you have to be careful with. Not because you might forget some solutions, which is what happens here. If you forget the plus or minus, you're going to have too few solutions that you're finding. But over there, it's the opposite. Frequently, when you do that, you actually find too many solutions in the end, and some of them are not correct, which is exactly what happened in our situation here. Because when you have something like 3 equals 3, and then you square both sides, it's 9 equals 9, which is fine. But sometimes one side will be 3 and the other side will be negative 3, which is not a solution to the equation at all. But when you square it, it's 9 equals 9. So you're hiding that difference in the positive and negative. So anyway, maybe you understood what I just said in terms of an explanation for why this is happening, and maybe you didn't. But the bottom line is that every time you choose to square both sides of an equation in the course of solving it, be careful. And when you get to the end, you find 4 solutions in this case, always go back to check if each one of them actually is a solution to that original equation. You're going to do that because you have very explicitly here what the angles are. You know sine and cosine for all 4 of them. You're going to plug those things into the original equation, and you're going to see that this one works and this one works, but this one doesn't and this one doesn't, which are the same solutions that we found when we did it in a different way before.